Welcome everyone to our next learning block in which we will be covering 2 units on chemical equilibrium. Chemical equilibrium is going to be a very new topic for everyone. It introduces a lot of things that haven't been covered before in chemistry and a lot of new ideas. It will build upon and is based upon some of the ideas you learned in thermodynamics and in chemical kinetics. But the work that we do in this, solving some of the math problems, a lot of new stuff here. So I want to go in a little more detail than I have in some previous units to talk about this unit and the concepts involved to give you a bit of an introduction before you get into the content. Before we talk about kind of what equilibrium is, let's just talk about what needs to be in place for a system to reach equilibrium. Now, when you hear the word equilibrium, maybe some terms come to mind like balance, homeostasis, and those are good good analogies for chemical equilibrium. First two conditions are that the reaction must be reversible. So the reactants must be able to be converted to products, but those products must also be able to convert it back to the reactants. Secondly, the reaction must be incomplete in both directions, both in the forward direction and in the reversed reaction. Another way of saying that condition is that there always must be some chemical species of every single chemical that's involved in the reaction present. Okay, we can't use up everything going in one direction. There's always got to be something present. We must have a closed system. Matter cannot escape this system as the reaction progresses. And in order for the system to reach equilibrium, we must leave it undisturbed. So we can't be continuously applying heat, can't be continuously changing the pressure. Now, we can do those things to a system at equilibrium, but once we do them, we have to stop and let the system return to equilibrium. So these are the conditions that must be present for a system to reach chemical equilibrium. Let's look at this video here. For some reason, I can't get it on a loop. When you watch this video, something just doesn't seem right. And yes, I'm playing it backwards, but it's not because I'm playing it backwards. It's that when you look at a combustion reaction like this, something doesn't seem natural about the reaction going in reverse, where gases from the air are recombining to form some sort of solid. So that's an example, a combustion reaction of an irreversible reaction, a reaction that goes to completion, and once the products are formed, they will never spontaneously go back to form the reactants. I wanted to show this because this is the exact opposite of what we're talking about in chemical equilibrium. And there's a lot of reactions which we have studied in chemistry, a lot of single displacement reactions, double displacement reactions, combustion reactions, a lot of those reactions which only happen spontaneously in one direction. Even if you mix the products together, they just don't recombine, right? Combustion reactions, I think, are the best analogy to think of because we've got the products of combustion reaction, carbon dioxide, water vapor, present all around us all the time, but they're not spontaneously recombining to form hydrocarbons and oxygen. So these reactions only happen in one direction. There's some terminology that you need to be aware of when we talk about chemical equilibrium. We'll use chemical equations, but they look slightly different, and we're going to use some different language, and it's important not to be confused by the terminology. So the first thing is that you're going to hear the word system described rather than a chemical reaction. And a chemical system is just talking about all of the chemical species that are present in on both the reactant side and on the product side. We don't talk about this as a reaction because there's actually going to be two reactions happening at the same time in an equilibrium system. To recognize that there's two reactions going on, we use a double arrow. And typically what you'll see are these half arrows here, kind of like the arrows you draw for electrons in electron configuration diagrams. We'll use the term left side and right side rather than talking about reactants and products, because every chemical species in an equilibrium system are both reactants and products at the same time. So we'll talk about the left side of the equation and the right side of the equation rather than reactants and products. Even though the reactions are happening both at the same time, forward and reverse reactions, we will still orient ourselves moving left to right. And what I mean by that is that when we talk about the forward reaction, we're talking about the substances on the left side, in this example, hydrogen and nitrogen, being converted into NH3 ammonia. So that would be the forward reaction. The reverse reaction would be ammonia decomposing back into hydrogen and nitrogen. So why do we have these two big units on equilibrium? Well, the first is that equilibrium turns out to be a very important aspect of chemistry in that equilibrium systems respond in very predictable and specifically quantitative ways. Basically, that means is there are mathematical laws which we're going to learn, and that we can make solid predictions about the way a system is going to be responding if we disturb it in a certain way. But most importantly, equilibrium systems are incredibly important in nature, in biology, specifically in physiology, and also in engineering and industry. So the applications of chemistry in a whole bunch of different areas are very important in terms of chemical equilibrium. Okay, we'll see some of those in both the first unit in equilibrium and in the second unit in acid-base equilibrium. Let's now talk about learning block 3. As with the previous learning blocks, there are two units, chemical equilibrium and then acid-base equilibrium. The one difference for this learning block is because of the number of assignments, there's two different due dates. The first set of due dates are on October 23rd, and that's for the first unit. The due dates for the acid-base equilibrium are on November 6th. That being said, just because the due dates on acid-base equilibrium are later on, I would encourage you to get through as much as you can in these 2 weeks, because there is another unit we're going to be doing, electrochemistry, and so it's going to overlap with when the acid-base equilibrium is going on. You just have an extended period of time to complete those assignments. The other thing to remember is that the next section of the organic molecule project, part B, is also due on October 23rd. My recommendation is to get through all of the content for the acid-base equilibrium unit by October 23rd. So you've learned the material, and then after that, you're just working on the assignments. And those final 2 weeks of the course, use those for assignment completion and working on that short electrochemical unit. I think the end of the term would be very rushed if you spend this entire 2 weeks just doing the first equilibrium unit and not even looking at the acid-base equilibrium unit. So think about your time management, look at the assignments which are going to be due between now and the end of the course, and budget your time accordingly. I personally find equilibrium a more challenging topic to learn just by text. So a few additional resources that I've already posted and that I'm going to be sharing with you over the next 4 weeks. First of all, there's some additional lesson videos which I've posted. My recommendation for those would be to first read through the content and then reinforce what you read by watching the video. Okay? Read through the content first, then watch the video. These aren't all my videos, but they are videos that I think explain the concepts quite clearly and correctly, which is not always the case when it comes to chemical equilibrium. I will also be posting video solutions to some of the common mathematical problems. Just as with the thermochemistry unit, if you have any requests for math problem solutions, send me an email, post it in the class lounge, and I can post a video with that. Watching someone do the video is often, watching someone on video post a mathematical solution is often more helpful than just reading the solution on paper. And remember, as a few of you have done, the student lounge discussion forum is there to ask question and answer. So if you have any questions, you can post them there as well. As always, if you have any questions as you move into the unit, I encourage you to contact me. I'm being very impressed with the amount of emails that people have sent me, but I can't emphasize enough. Ask those questions early on, okay, rather than waiting until the day before the learning block is due. The more time we have to address the issues that you're having with learning, even no matter how small they are, the more beneficial that's going to be for you.